Out beyond the familiar orbits of the gas giants Jupiter and Saturn, at the very edge of our solar system, lies a world whose mysteries have intrigued astronomers for centuries. This world, the seventh planet from the Sun, is Uranus. But for all our scientific knowledge, Uranus remains one of the most elusive and enigmatic planets in our solar system. A world that holds secrets that even the most powerful telescopes have struggled to uncover. Until now, with the launch of the James Webb Space Telescope, humanity has a new, unparalleled tool to peer into the depths of space. JWST's capabilities are poised to unlock the long-standing mysteries of Uranus, revealing more about its icy composition, unique atmosphere, and extreme weather systems than ever before. The secrets of this distant planet are now within our reach. Uranus is an ice giant, a type of planet that sits somewhere between the gas giants like Jupiter and Saturn and the rocky worlds like Earth. Unlike the gas giants, which are made primarily of hydrogen and helium, Uranus is composed of heavier elements, substances like water, methane, and ammonia. These compounds form the icy and liquid interiors of the planet, creating a deep, cold atmosphere far removed from the fiery clouds of Jupiter or the iconic rings of Saturn. But it's not just the chemistry that makes Uranus fascinating. The planet's most striking feature is its tilt, an axial tilt of more than 90 degrees, causing it to essentially roll along its orbit, with one pole facing the sun while the other remains in darkness for decades. This extreme tilt results in seasons that are unlike anything we see on Earth or the other planets. Each hemisphere of Uranus experiences 20 years of continuous sunlight followed by 20 years of darkness. How this tilt came to be and how it affects Uranus's weather remains one of the greatest mysteries of planetary science. Was it caused by a collision with another body early in the planet's formation? Or is there a more gradual process at play? Until now, we've had only glimpses of the answers, thanks to earlier observations by Voyager 2 in the 1980s. But these were limited, and scientists have been waiting for a more detailed view of Uranus's extreme tilt and strange atmospheric behavior. Now, with JWST, we're on the verge of discovering the true dynamics of this extraordinary planet. What makes the James Webb Space Telescope so revolutionary is its ability to observe the universe in infrared wavelengths, light that is invisible to the human eye but crucial for understanding the hidden structures of distant objects. The thick clouds that surround Uranus, composed largely of methane, obscure the planet's surface in visible light. But in infrared, JWST can pierce through these clouds to reveal the secrets hidden beneath. With its large, 6.5-meter gold-coated mirror, JWST captures more light than any previous telescope, allowing it to peer deep into Uranus's atmosphere. By detecting the planet's thermal emissions, heat radiated from its core and atmosphere, scientists can map temperature variations, identify atmospheric gases, and study cloud formations with incredible precision. For the first time, we'll be able to measure temperature gradients across Uranus's atmosphere, tracking how heat moves through its layers, potentially revealing new layers of chemical composition we've never seen before. But the real breakthrough is JWST's ability to track the weather patterns of Uranus in unprecedented detail. Winds on Uranus are among the fastest in the solar system, reaching speeds of over 900 kilometers per hour, 560 miles per hour. These winds, combined with the planet's peculiar tilt, create atmospheric conditions that are incredibly difficult to understand. But with the advanced infrared technology of JWST, we can now watch how these winds move, how cloud systems form, and how they change over time. One of the key goals of the JWST's mission to Uranus is to better understand the planet's atmospheric composition. Scientists are particularly interested in the distribution of methane, a compound that makes up around 2% of the planet's atmosphere. Methane plays a critical role in the thermal structure of Uranus, and understanding its abundance and movement through the atmosphere could offer crucial insights into the planet's formation. JWST will also examine the planet's cloud structure. The thick clouds that envelop Uranus are made up of methane ice, but beneath them, scientists suspect there may be layers of clouds composed of water and ammonia. These deeper clouds are invisible in visible light, but JWST's infrared capabilities allow it to see through the methane clouds and explore what lies beneath. By analyzing how these clouds interact with heat and light, scientists can learn more about the planet's internal processes and how they drive its unusual weather patterns. Uranus is also home to a faint but intriguing ring system made up of dark, icy particles. These rings are much less pronounced than Saturn's magnificent rings, but they hold fascinating clues about the planet's history. JWST's infrared capabilities allow scientists to study these rings in far greater detail than ever before, revealing their composition, size, and distribution. What causes these faint rings to exist, and how do they interact with the planet's moons and magnetic field? These questions have long remained unanswered, but with JWST's observations, we may soon have answers. Speaking of moons, Uranus has 27 known moons, each with its own mysteries. Among them, Miranda stands out, an icy moon with a surface that looks like a patchwork quilt of fractures, valleys, and ridges. The moon's surface suggests it may have experienced a violent history, one of impacts, tidal forces, and perhaps even a catastrophic event that shattered it before it was reassembled. What caused Miranda's bizarre landscape? And could there be subsurface oceans, similar to those of moons like Europa or Enceladus, that might harbor the ingredients for life? JWST is equipped to investigate these moons in detail, and the answers it uncovers could radically change our understanding of icy moons across the solar system. The mission to Uranus is not just about studying one planet. It's part of a much larger quest to understand the formation and evolution of planetary systems, our own solar system and beyond. By studying Uranus in such detail, we can learn about the processes that create ice giants, planets that are common throughout the galaxy but largely unexplored. Furthermore, the study of Uranus helps astronomers better understand the thousands of exoplanets we've discovered around other stars, many of which are similar in size and composition to Uranus. These distant exoplanets may have similar atmospheres, weather patterns, and moons. As we continue to search for habitable worlds in distant star systems, studying Uranus helps us refine our models of planetary formation and evolution, bringing us closer to understanding the nature of planets beyond our own. In exploring Uranus, we are not just unlocking the secrets of one isolated planet. We are extending our reach across the universe, connecting the dots between the worlds in our own solar system and the countless exoplanets scattered across the galaxy. The data we collect from Uranus will teach us about the fundamental forces that shape all planets, how they form, evolve, and interact with their stars. The discoveries that await us in Uranus's atmosphere, its rings, its moons, and beyond will help scientists answer profound questions about the origins of planets and the processes that govern their lives. It is through these discoveries that we begin to understand our place in the cosmos, and perhaps what life might be like on distant worlds. The universe is vast, its mysteries beyond our imagination. But with the James Webb Space Telescope, humanity is at the forefront of exploring the unknown. As we gaze deeper into the cosmos, we are learning not only about the planets and stars that surround us, but about the very nature of the universe itself. Uranus is just one of many stops along the way. But with each new discovery, we move closer to understanding the incredible, infinite expanse that we are a part of.